Hey everyone, this is Evgeny and I welcome you in another series, another episode about LangGraph introduction. And in this video, we are trying to make our feet wet with the memory concept. So we're going to look deeper in the memories and what you can do with it. Alright, and let's start from the very basics. We spent already some time on memories, and just to refresh your memory, we were trying different techniques how to pack the very long list of conversation, list of messages we had for our chatbot. And one technique was summarization. So we can grab the whole bigger discussion, summarize it in a couple of paragraphs. And so we can keep the conversation going, and we can keep our chatbot aware of the previous conversations. But this all was happening in the scope of the single thread. So this was part of so-called short-term memory. So when we are in the conversation, we can refer to the previous facts. But for example, if you create a system where you can, like an AI agent, and you can go back to your AI agent 1 month later, for example, well, that's not the case already, because it's another thread, it's another conversation, and then we are missing completely all these summary things, or maybe facts from previous talking. Well, that's why it's called short-term memory. And in the opposite, we have another concept, which is long-term memories. And so in short, the way you can see it, that it's kind of, you have the short-term memory, and this is kind of your conversation. So you're talking with another person, and you still can remember what's happening like 5 minutes ago. So you can keep the dialogue based on this information. But at the same time, you have some knowledge about this person, like who is that, how looked like in different interests, maybe history, like 5 years ago what happened, etc. And all this comes from your personal long-term memory. And you can use this analogy when you convert this to AI agents and LangGraph. And so we do have the short-term memory, and this is our conversation. And for long-term memory, we can keep different facts about the user. For example, it could be user profile, name, interests, different preferences maybe. It could be specific AI expectation, behavior, or something else, or maybe funny facts. But this is something that is not related directly to the conversation, but helps you in your current talking. So this is the idea, and this is the difference between short-term memory and long-term memory. And practically what's happening, you're feeding both type of memories to the LLM to help LLM or model produce the much better response. So that's the idea. And as noted here already, we have different concepts in LangGraph. For short-term memory, we have checkpointers, and we've been looking a lot into this concept, the way how it's stored in the thread. We had the thread concept as well. And for long-term memory, it's completely different type of objects, and the name is store. So we can use both checkpointer and store together in the conversation to provide all this short and long-term memory. So this is the idea. Right, okay, and talking about some technical details about LangGraph storage or store object, we have specific hierarchy here. So in general, every store contains of different namespaces. And namespace, it's kind of logical way of grouping different data, like it could be user profile, user memories, user preference, something like that. And inside every namespace, we are keeping the real memories in the way of key value pairs. So you have a key and you have a value, and this value is kind of a JSON object, so you can put whatever you want there, and this will be stored. As an example, I can show here the snippet. So we have in memory store, and the namespace is Evgeny, and it's me. In fact, so it's this namespace keeps some interesting facts about me, Evgeny, right? And so I would define a key as fun fact number 1, and then the value would be that that Evgeny likes to ask philosophical questions late at night. And also I can provide a source where this fact was gathered. Maybe we need it in the future, who knows, right? So what's happening next? It's very easy. We are having the in-memory store, and this is from LangGraph store memory. And we can just put our fact here, so we're providing a namespace, which is a pair of values here. So again, in facts, we're providing key, and we're providing value as well. So if you let me apply that, it's there, and now we can do different things with that, but most probably the main point is if we can extract the information we need for that, right? So number one method here is searching, and we can, for example, fetch all the memories for specific namespace. And since namespace is practically it's something about me, a specific user, then we get all the memories about the user. And this is how it looks like. It's a list, and well, at the moment we have the single fact here stored. And if we just show it in a better way as a dictionary, we can see that, okay, what we have here, the namespace is Evgeny facts, the key is here, fun fact 1, and we have a value which we stored previously. And it's interesting also the creation of date is stored here. So this is the most significant data, right? And another way we can use it, we can get a specific memory based on the key as well. So if I provide the same namespace as we had previously and the same key, fun fact 1, and try to fetch it from the memory, then we can fetch specific fact as well. So this is the way. All right, well, that was a bit theory, and let's try and apply it to something real, I would say. And normally the best example here is using a chatbot, and we constructed chatbots in the past already, but practically you know that they all had only short-term memory. And now let's try to expand this chatbot as a long-term memory. So how we are doing this? And again, just referring to the image above, we have short-term memory, and this one should keep information about the current conversation, and it uses checkpoints. And long-term memory, it keeps info about some more stable facts like user's profile, preferences, specific things, and it's using memory store. And again, this is not that you're not allowed, for example, to keep user profile in your short-term memory. It's just not the best way to do these things. So you should always think about, is this information about our current conversation or interaction, or this is something which will be helpful in the future conversations, for example. So this is the division. You should make it in your head first of all, right? And how we are doing this, it's pretty simple. I put here some information about structuring, so it's clear for you. And we have a configuration. We used that in the past already. What's new here? We are adding user ID. So we have a thread ID and user ID. And then for the storage, also we have a namespace as a memory and user ID taken from this one. And key we have is user details. So you need to remember about this structure because we're going to reuse it later. And what do we have here? Let's take a look. We have a chat node. And this one, what's happening? First of all, it takes the configuration and additional parameter. It takes store as well. And this is an important thing. So every node can have access to storage and fetch some data from there. So what we are doing, we are fetching a user ID from configuration object. And again, this is the structure for configuration objects. So it's configurable and user ID. And so do we have here. And then we are fetching user details from the store. We have the namespace as memory and user ID, and I mentioned it here already, just to refresh memory. And we're fetching user details. And what we're doing next, we are constructing a prompt, and this is about chatting. And we are saying, okay, that you're a helpful assistant with memory capabilities, so you know something about the user. And what's interesting here as well, we ask him to be more friendly. So if this chatbot has any specific user information, profile, interest, something else, this one should be used in the response. Well, and we are passing the memory we have about the user. So it's user details content. And here, take a look at that. If we don't have anything, then we're just printing no existing details found. Otherwise, we are putting what we have in our memory. So this is the chatbot node. And another one is about updating memory, because it's not the normal way, right? We're working with application, we go to configuration and put some data. This is AI application, so it tries automatically fetch all the details about user, about the conversation in the background kind of mode, and update its memory. Like practically this is the same as happening with us human beings, right? So we are trying to simulate this approach here. That's nothing more, right? So what we do here, we have the same. We have user ID from configuration object. We have the namespace. We have key, which is the same. We fetching user details. We have another system message, and this one is responsible for updating and maintaining user memories. And we are providing the current memories, which we have already, and then asking to review them, to review the conversation, like which goes below, because we are still using all the list of messages, and try to fetch and extract some new facts about the user. And so if facts are here, then respond with these new facts for us. And finally, we are updating our storage. We are putting the memory object again with the new facts. So that's the idea. And the rest is simple. We are just building our graph. It contains of two nodes, chat and update memory. And let me compile it. And interesting, we have now long-term memory and short-term memory, and we are using it here in the compile function. So we're defining check pointer to short-term memory and our storage to long-term memory. And so just to visualize this approach again, we have a chat mode, chat node and chat mode where you're talking with your assistant. And then based on the conversation, your memory will be updated. And so if you continue this interaction and start the second round in the same thread, it will be like normally as the previous, like you had chat and updating information, everything happens like automatically as before. But if you start a new thread, for example, after some time, 1 month later, then memory will be used here. That's the idea. And let's give it a try and see if it works at all right. So we have a thread, we have a configuration here, we define thread ID to 1 and user ID to 1, and we are starting our conversation with a simple question. So I'm saying, how are you? I'm Evgeny, I'm a software engineer, I need your help with my project. And this is a task manager Java Spring Boot application. Like for demonstration purposes, I'm trying to provide a lot of facts here about myself so we can see the way it works. Maybe not every single fact is necessary here in the conversation. Maybe not this is the way you would chat with your assistant, but just for demonstration, right? We are trying to feed a lot of different facts about myself. And we are just printing out the conversation happening here. And pretty standard answer, hi Evgeny, I'm doing well and thank you. And what specific challenges or questions do you have about your project? Nothing really exceptional here, right? And let's check the memory. So we have the user ID, we have the namespace, we have the key, and we already have our long-term memory object, so we can fetch the information from there. And look at that, what we have. We have the memory, so name is Evgeny, profession is here, software engineer, and current project is task manager Java Spring Boot application. So 3 facts was extracted by this update memory node. Okay. And let's try and pretend that it's 1 month later practically. And so we are continuing our conversation, but this time the app was closed completely. We are starting a new thread ID with a 2, but we are still the same user. And we are just asking something like, okay, so how can I set up security configuration? And we know already that since this thread ID is a completely new one, then normal way your assistant is not aware of all the context. It's kind of the first message you're asking in this conversation. But let's take a look. What will be the response? And take a look at that. It says, okay, sure, Evgeny, it knows my name already. For your task manager, Java Spring Boot application, it knows about my project I'm currently working on. And then it provides specific information about that. And it knows that since this is Java boot application, that the answer should relate Spring security. And the whole information was taken from long-term memory, right? All right, and as the final step here, let's take how it works in LangGraph Studio. So let me copy my first prompt or request. We are just trying to repeat the same experience as previously, but using the LangGraph Studio. And I'm going to Studio, and what we can see here is exactly the same chatbot with long-term memory, and here you have the memory panel, and it's empty at the moment, so nothing is stored. And what we are doing, we are adding a new message and just pasting it, and hey, how are you? I'm Evgeny, and here are my facts about myself, and this is what I'm working on. So I'm submitting this thing, and it's chat. It says, okay, hi Evgeny, I'm doing well, and updated memory happened as well. And the first turn, the first round finished. And if you go to the memory panel right now, we can see, okay, the key was added. So the memory and user default user, this is the our namespace, and a new key was added here, and we can see that it's a name, occupation here, and current project. So more or less the same as previously, right? And now let's give it a try and create this second question. And so I'm creating a new thread, so it's a completely new one. It does not aware of the previous conversations. And here I'm asking how can I set up security configuration and submitting it. And again, it's aware of our previous conversation because of long-term memory. So it says, hi Evgeny, that's even code snippet. So hi Evgeny, your configuration is set up for your task manager Java Spring Boot application. You can use Spring Security, and here's how you can do it. So pretty nice thing. All right, that was very basic information about storages and how you can organize long-term memory using storage in LangGraph. In the future video, we'll try different techniques. We will be looking more deeply into these concepts and try some different techniques how you can organize your long-term memory better, and I will show you some really interesting, cool stuff. So far, I was Evgeny. Thanks a lot for watching the video till the end. I really appreciate that, and I will see you next time in the next video about LangGraph. See you, and bye-bye.